Alright everybody, what's going on? This video we're going to look at Taylor polynomials. So we got 3 examples to work, so let's go ahead and get started. So it says let f be a function with f prime, f double prime, and the nth derivative of f defined at a. The nth order Taylor polynomial for f with its center at a, denoted t sub n, has the property that it matches f in value, slope, and all derivatives up to the nth derivative at a. That is, t sub n of a equals f of a, and then the derivative of t equals the derivative of f of a, and then the nth derivative of t of a is equal to the nth derivative of f of a. The nth order Taylor polynomial centered at a is t sub n of x is equal to f of a plus f prime of a times x minus a times the second derivative of f of a over 2 factorial times x minus a squared all the way to the nth derivative. And more compactly, t sub n of x is equal to, and then this is just a, well, just like it says, a more compact way to write this. All right. It's just the kth derivative of f of a over k factorial times x minus a to the k, where k is 0, 1, 2, all the way to n. All right, so basically all we're doing is we're just using this right here to come up with a Taylor polynomial. All right, so let's go ahead and get started on this example here. So it says find the Taylor polynomial T3 centered at x equals 0 for f of x is equal to sine x. All right, so in this problem, a is equal to 0, and we want to find T3. So to do that, we're going to use this, and we're going to take it to the third derivative because we're looking for t sub 3. All right, so that means, see, according to this, we need to go all the way to the third derivative. So let's do that. We've got f of x is equal to sine x. So f prime is cosine x. F double prime is equal to negative sine x. And then the third derivative is equal to negative cosine x. All right, so now let's look and see what we need. So let's just go ahead first and write down the formula. I'm going to write it down right here. All right, so that's going to be f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed. So there's our Taylor polynomial. Now remember, in this case, a is equal to 0. All right. So you can see we need to evaluate f at 0. F prime, we got to evaluate at 0, f double prime, and f triple prime. We've got to evaluate all of these at 0. So we have f of 0 is sine 0, which is 0. F prime of 0 is cosine 0, which is 1. f double prime of 0 is negative sine of 0, which is 0, and f triple prime of 0 is negative cosine of 0, which is negative 1. All right, so now just plug everything in. So we get t3 of x is equal to f of a, which is 0. See, we evaluated it right here, plus f prime of a. Well, f prime of 0 is 1 times x minus 0. So I plug the 0 in for a, and then plus f double prime. So that's going to be 0 over 2 factorial times x minus 0 squared, plus, and then f triple prime of a is negative 1 over 3 factorial times x minus 0 cubed. And so this is going to give us so this term is 0. This right here is just x. This term goes to 0 because this is 0 here. 0 times all this is just 0. And then it's going to be minus 1/6 x cubed. And this is our Taylor polynomial. Now, let's take a look at the graphing of this. All right. So what I want to do is I want to graph f of x equals sine x. I want to graph this, and I want to graph the Taylor polynomial on the same coordinate system. And let's just look and see how it fits around x equals 0 or around a equals 0. Okay, so let's take a look at that graph. All right, so let's look at the graphs. So I'm going to graph our function f of x equals the sine of x, and there it is. All right, so let's see. Let's kind of zoom in a little bit. So that's our actual graph of sine. That's the actual graph. Now let's put in our polynomial we found. We found t sub 3 of x. So that's t of x is equal to, and that's going to be x minus 1 over 6 x to the third. And there's here the blue is our Taylor polynomial, and you can see it looks like it's laying just right on top of it. You see that? But notice here, the further we get away from where x is equal to 0 here, the further we get away, you see that? The more these graphs separate. Now, if we took it out to like t sub 5 or t sub 7, I wonder what that would do. Well, I'll tell you what, let's graph t sub 7. We'll call that s of x for 7. And I know we didn't find it, but let's I know what it is. So let's go ahead and find that, or graph. Okay, so now I have T7, which is this S of X. That's the green one. And so let's hide it. And so you can see there's the TX, the T3 that we found. I've got T7 hidden right now, but let's unhide it and watch that green graph pop in there. You see that? You see how it goes in there? And see how it goes out even more, where it looks like it's just laying on top of that graph. And of course, there's the blue one, there's the red, and here's the green. So you can see when we take it out more how it fits on that graph even more. All right, so that's, that's what it looks like. That's what you're finding. You're finding a polynomial for sine x. All right, around, in this case, a is equal to 0. So I hope the graph helps you. I hope it helps you get an idea of what you're doing. All right. So now let's go back to working problems. All right. So our next example, it says find the Taylor polynomial of order n equals 3 for f of x equals e to the x centered at 0. And then for part B, use the polynomial in part A to approximate e to the 0.1 and find the absolute error f of x minus t sub n of x in the approximations. Use calculator values for the exact values of f. All right, so we're going to basically do the same thing that we did in the first problem to find part A. All right, and on this problem, I'm not going to graph it like I did the other one. Okay, we're just going to find it, and then, if you want to go and get some, on some software and graph it and look at it, you can. All right. So I need n equals 3. So I'm looking for the t sub 3. So I need all the way to the third derivative. So I have f of x is equal to e to the x. And then, well, this one's easy because the derivatives are all just e to the x. And we know here that, let me write it right here, a is equal to 0. All right, and now evaluating each of these at 0. Well, that's easy. These are all going to equal 1. Okay, e to the 0 is just 1. All right, so let's write down our formula. And, I understand you may not need to write all these formulas down every time, but, I think it helps just write the formula down, see what you're trying to find, and then you know exactly what you need to get to plug this stuff in. So that's f of 0 plus f prime of 0 times x minus a plus f double prime of 0 over 2 factorial times x minus a squared plus f triple prime of 0 over 3 factorial times x minus a cubed. And now we just plug everything in. So that's t3 of x is equal to, well, f of 0 is 1 plus 1 times x minus 0 plus 1 over 2. 2 factorial is 2. And remember, and f double prime of 0 is 1. And that's times x minus 0 squared plus, and then f triple prime of 0 is 1 over, and 3 factorial is 6 times x minus 0 cubed. And so that's going to give us t3 of x is equal to 1 plus x plus 1/2 x squared plus 1/6 x cubed. And so this is our Taylor polynomial. All right, so that's part A. Now for part B, they want us to find the absolute error. So all we're doing here is we're evaluating our function, f of x, which is e to the x. We're evaluating it at 0.1. We're actually going to plug that into our calculator. And then we got to evaluate the third Taylor polynomial at 0.1. And let's see how close we are. So we have f of 0.1 is equal to e to the 0.1. And when we punch that into our calculator, we get 1.105170918. And then when we evaluate our Taylor polynomial at 0.1, that's 1 plus 0.1 plus 1/2 times 0.1 squared plus 1/6 times 0.1 cubed. And let's see what we get there. All right, so this is what we get when we plug 0.1 in to t sub 3 into this function. Now, the absolute error here, that is going to be f of 0.1 minus t sub 3 of 0.1, which is 1.105170918 minus its absolute value 1.105166667. And so let's see what that gives us. And so this is our absolute error. And you can see how close it is. And all we did is we just went to the third Taylor polynomial. Okay? And you can see it didn't take very long, and we're pretty accurate here. Okay? All right. So now let's look at the last example, and it's going to be a little bit different than the first two. They want to use polynomials of order n equals 0, 1, 2, and 3. So this is like 4 different problems in one. Okay, they want us to find t0, they want us to find t1, t2, and t3 to approximate square root of 18. Now, you may come across a problem and it may just say find t3 to approximate the square root of 18. It's just in this problem, they want us to find 4 Taylor polynomials. And then what we'll do is we'll just kind of compare them and see. All right, so for this problem, our f of x is equal to the square root of x. That's our function, square root of x, because we're looking for the square root of 18. All right, and we want a. We're going to pick a to be 16 because 16 is close to 18. And 16, it's a perfect square root, so it's easy for us to evaluate the square root of 16. That's why we're choosing it. All right. Now, in a lot of problems, and probably the problems you'll have on the test, they'll tell you what a is. Just like in the first 2 problems. It's just in the first 2 problems that we worked in this video, they told us a was 0. They could have very well have told us that a is 1 in the previous 2 problems. They just told us 0. But for this problem, we're going to choose a as 16 because it's close to the square root of 18. All right, so let's go ahead and find our derivatives. Okay, so for n equals 0, well, we just need the function f. For n equal 1, we need the first derivative. We need to go all the way to the first derivative. For n equal 2, we need to go to the second derivative, and for n equal 3, we need to go to the third derivative. So let's just go ahead and find all the way to the third derivative, and then we'll use what we need to. So I've got f prime, and also keep in mind that that square root f of x, that's the same thing as x to the 1/2. I'm going to change that square root to a 1/2 power. Makes it easier to find the derivatives. So I've got f prime of x is equal to 1/2 x to the negative 1/2. F double prime of x is equal to negative 1/4 x to the negative 3/2. And f triple prime of x is equal to, what is that, 3/8 x to the negative 5/2. And then I'm going to need to evaluate each of these at 16. So let me move this a equals 16 out of the way. A equals 16. So I've got f of 16 is equal to the square root of 16, which is 4. F prime of 16 is, I'm just plugging 16 in for x. That is going to be, let's see, that's going to be 1/8. And f double prime of 16 is going to be negative 1/256. And f triple prime of 16, that is going to be, let's see, 3/8,192. All right, so all I'm doing is I'm just plugging 16 in for x. And this is what we get. So let's find our Taylor polynomial. So let's find t0. So t0 of x is just equal to f of a. So that's going to give us t of 0 is equal to f of a. Well, what's f of a? That's up here. That's 4. All right, so that's t of 0. Now, let's find t1. All right, so t1 of x is equal to f of a plus f prime of a times x minus a. So that's going to give us t1 of x is equal to, well, f of a is 4 plus f prime of a, which is 1/8, times x minus 16. So this is t1. Now let's find t2. So that's f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared. And so I get t2 of x is equal to f of a, which is 4. See, we did that right up here. And then plus f prime of a. Well, f prime of a, that's 1/8 times x minus 16 plus f double prime of a. Well, that's negative 1/256. So that's negative 1/256 over 2 factorial, which is 2, times x minus 16 squared. All right. And so that's going to give us T2 of x is equal to 4 plus 1/8 times x minus 16 minus, and that's going to be 1 over 512 times x minus 16 squared. And so there's T2. And now let's find T3. So T3 of x is equal to f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a to the third. All right, so basically, look at this. This right, you see the first 3 terms here? That's just T2. See how this is the same thing as this. So I can just copy this down. All right. So that's going to be T3 of x is equal to 4 plus 1/8 times x minus 16. And then that's going to be minus 1 over 512 times x minus 16 squared. Plus, and now I need to plug this in, f triple prime of a, that is 3 over 8192. 3 over 8192, make sure I wrote that down right, yep, over 3 factorial, and 3 factorial is 6, times x minus 16 cubed. And so that's going to give me T3 of x is 4 plus 1/8 times x minus 16 minus 1 over 512 times x minus 16 squared plus, and then that's going to be 1 over 16,384 times x minus 16 cubed. And there's T3. All right, so now let's find the absolute error for each of these. Okay. So the absolute error is going to be, remember, we did that in the second example. That's going to be absolute value f of x minus Tn of x. And let's just find it for 0, 1, 2, and 3. All right. All right, so f of x, or f of square root of 18, or the square root of 18. All right, so that's going to be absolute square root of 18 minus T0 of 8. I'm sorry. No, that's right. T0 of 18. Well, that's going to be the square root of 18 minus, and what's T sub 0 of 18? Well, you come back up here. Well, T sub 0 is 4. Okay, it's a constant. So that's 4. And this is going to give us 0.24 rounding. Okay, so you can see we're off a little bit. But then when we do the square root of 18 minus T1 of 18, and I'm just going to write the answer down. I'm not going to write all this out. is I'm just doing the square root of 18, whatever that is, punched into my calculator, minus, and then T118. So to find this, I'm going to take the 18 and I'm plugging it in here for x. Okay, in T1. I'm just plugging 18 in here and then punching that into my calculator. And what that gives me is 0.0074. All right. And you can see how it gets better as we go. All right. So now the square root of 18, I punch that in my calculator, and then minus, and then I take the 18 and I plug it into this one. Plug it in for x, and then you plug that into your calculator. And that gives me 0.00045. And then I'm going to do the square root of 18 minus T3 of 18. And so for this one, I'm going to take the 18 and I'm going to plug it in for x right here. And of course, you'll punch all that into your calculator. And I get 0.00035. And so you can see the higher n is. So if I went and found T4, I'd probably get an even better approximation. But you can see how close this is. So, you know, Taylor polynomials, they're not difficult to do. I mean, I think the best thing to do is just write down your formula. Write your formula down, what you're needing to find, and then, you know, find all that stuff and plug it in. And it's just like this formula here for T3. If they asked me to find, if I were to find T4, then what would I do? Well, I would just add the fourth derivative of a over 4 factorial times x minus a to the fourth. I would just keep going. So, you know, that's how you do Taylor polynomials. They're really easy to do. It's just, you know, follow that formula. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all later.